Hello class, this is my first attempt at these online video lectures. So the idea of these is that I'm going to try to hit some of the topics in each of the sections that I view as the most difficult to understand, try to do some example problems in that, and then hopefully that'll lead you to better understanding of the topics. So in this first one, we're going to talk about the concept of correlation. This is out of the very first chapter that we cover, the very first section in the very first chapter, which is chapter 7, section 1. The basic idea of correlation is understanding and identifying, does data have a trend? When we talk about correlation, there's three different types of correlation that we can have. Either a positive correlation, negative correlation, or no correlation. To better understand what those three mean, we're going to look at three different graphs here. The idea of a positive correlation is similar to the idea of a positive slope. And really when you're thinking about all of these, you can connect them somewhat to the idea of the slope of a line. So if you'll notice these data points on this graph, on this XY axis, in general are trending up and to the right. So if I were to draw a line that kind of fit through the middle of these data, this line would have a positive slope up and to the right, and we would say, generally speaking, this data has a positive correlation. In a similar but opposite way, you would notice that this data is trending down and to the right. We would say that this data has a negative correlation. And then finally, if you have a scatter plot of data where there's really no trend, either upwards or data, and the data is just kind of all together in kind of a rectangular shape, really the line that best fits this data would be a horizontal line. And you may remember from your previous study of lines that horizontal lines actually have a slope of 0, and in terms of correlation, we would say that this has no correlation. A couple other things that are important when it comes to correlation. The tighter that the data is together, the stronger the correlation is. So let me show you two example graphs of what I mean by that. Let me give you two graphs that both have a positive correlation. Okay, so this first scatter plot here, if I were to draw what they call in your textbook the line of best fit, this line of best fit, which is the line that goes the most through the middle of this data, would look something approximately like this. They actually have tons of different free computer tools that could actually give you the exact equation of that line, but for our purposes, we're just going to estimate. So that line has a positive slope. We would say this data has a positive correlation, but it's not a very strong positive correlation because, as you can see, there's a pretty decent distance from a lot of these points to that line, meaning that the points aren't clustered together very closely. On the other hand, consider a set of data that looks something more like this. This data is obviously clustered a lot closer together. It actually resembles more of a straight line, a lot more than this data does. And if I were to draw the best fit line here, something like that, you notice that the distance between all of these dots, these data points in the line, is very small. This would be a strong positive correlation, where this would still be a positive correlation, but we would call it a weak positive correlation. And you can apply the same principle to negative correlation. Now, one other concept I want to cover under the idea of correlation is how do we use this to help us solve problems. You have a couple of problems in your 7.1 homework that are centered on this topic. So let me make up an example for you of how this can be useful. The context that I'm going to create here is on my two axes of my graphs here. I'm going to have on the y-axis total sales, and I'm going to have on the x-axis outside temperature. Okay, and the context that we're going to be using, let's say, is of an ice cream truck. Now, it would stand to reason when you're selling ice cream that within reason, as the outside temperature goes up, your total sales would go up. You're probably going to sell significantly more ice cream if you're an ice cream vendor in the summer than you would in the winter. So when the outside temperature is low down here, your total sales would also be low. So these data points that I'm just making up on here, they would represent different days where you charted first the outside temperature and then the amount of total sales. As the outside temperature rises, in general, not 100% of the time, but in general, we would expect the total sales to go up. So we may end up with a scatter plot that looks something like this. What you can do with data on this, right now these are all just data points. We can't really put them into an equation. They don't have an equation of a line. So what we can use is something called a trend line, or you may also see it referred to as a best fit line, which is very simply the line that best fits the most of these data points. The way you locate that is by trying to find the line that goes, think of it as through the center of as many of these data points as possible. So I'm just going to eyeball that. On this, that would be something approximately like that. Now, because that's just an estimation, I may be a little bit off there, but you get the general idea. Once I've established a trend line or a line of best fit, there's two things I can do with that. One, if I have computer software or graphing calculator, I can actually use the graphing calculator to show me what is the actual equation of that line in the y equals mx plus b. This is the slope-intercept form of a line. And if I don't want to go that far, and I think in your homework you don't even have to go that far, but I just want to use this line to make predictions. I can use this line to make predictions about my data. Okay, so let me give you an example about that. Let's say that right here on the outside temperature is 90 degrees. And I'm being asked to predict, according to your best fit line, how much sales will you have on average when the outside temperature is 90 degrees? Well, if I take 90 degrees on this x-axis and I run it straight up to the point where it intersects my best fit line, then I can run this point straight over to my y-axis, and whatever this amount is right here, let's just make up a number, let's say that that's $1,500, that would be what I would predict my total sales to be when the outside temperature is 90 degrees. So trend lines allow us to make predictions. Hopefully this video is helpful with the concept of correlation. You'll see that there's a couple of problems on the homework that are similar in nature to this. Please reach out to me in an email or some other method if you still have questions on the topic.